The following topic occurs in two parts. First, we're going to look at how to solve a compound inequality. A compound inequality is the result of combining two or more inequalities together using the logical connectives or and. Once we've seen how to solve a compound inequality, the second step will be to use interval notation to express our answer. Interval notation is something we can also use to express an inequality in other contexts as well, so we'll see how we can use it at the end of this problem as a way of expressing our final answer. Here we have a compound inequality because it's made up of two inequalities, u minus 3 is less than or equal to negative 2, as well as 5u is less than 10. These inequalities are connected together by the logical connective word or. Don't underestimate the importance of that word. You'll see how we'll use it in a few steps. The first step to solving a compound inequality is to solve each of the two inequalities separately. To solve the inequality u minus 3 is less than or equal to negative 2, we need only to get the u by itself by adding 3 to both sides. We end up with u is less than or equal to 1. To solve the inequality 5u is less than 10, we need here to divide on both sides by 5, giving us the inequality u is less than 2. Next, once we've solved each of the inequalities separately, we'll sketch the sets that they describe separately on a number line. For example, to sketch the inequality u is less than or equal to 1 on a number line, I'll shade in the area which starts at 1 and proceeds infinitely far to the left. In other words, I have just shaded in all of the numbers on the number line which are less than or equal to 1. I can reinforce the fact that 1 itself is included in this inequality because of the less than or equal to symbol here. 1 is actually a solution of this inequality. I can reinforce that on my diagram by using a filled-in circle. So anytime we're sketching an inequality on the number line that involves a less than or equal to or greater than or equal to symbol, we'll use a filled-in circle to indicate that the number at which that circle is placed is included in our solution. So now that we've sketched the first of these inequalities on the number line, let's also sketch the second one, u is less than 2. This set will also be a line extending infinitely far to the left and ending at 2, but here we'll use an open circle instead of a closed circle because 2 itself is not included in our final answer. Having sketched each of these inequalities separately on the number line, our last job is to combine these two sets together using that logical connective, whether it's or, as it is in this case, or if it's and, as it might be in a different example. Those two logical connectives have very different meanings. If I take two sets and I, quote, or them together, what I'm doing is I'm including as an element of our answer any number which belongs to either or both of the original sets. In other words, to or two sets together, we're just going to take those two sets and just glue them together and take everything. Meanwhile, if our connective were and instead of or, then in order for a number to be part of our final answer, it would have had to belong to both of the original sets. So if the word were and instead of or, we would take only those parts of the number line where our two sets overlapped one another. Since in this example our connective is or, we're going to take our two sets, glue them together, and take everything. In that case, we've now sketched our final answer as the set which begins at 2, not including 2, and extends infinitely far to the left. In this example, if we had had and instead of or, we would have taken only where these two sets overlapped, giving us the set which begins at 1 and extends infinitely far to the left. Now that we've combined our two inequalities together using the logical connective, our last step is to write our answer in interval notation. To do that, let's remember that our original problem was an OR. And so we'll use our answer that we got with OR here. And let's take a look at what's involved in the process of writing an inequality using interval notation. The first step is to graph that inequality on the number line. Here we've already done that. It's the graph that we see at the bottom of the screen. The next step is to look at that set that you've sketched on the number line and identify what is its lower endpoint. In other words, how far to the left does this set go on the number line? In our example, the set goes on forever toward the left of the number line. And anytime a set goes on forever, we use either negative infinity or positive infinity symbols to indicate that it has no lower or upper bound. Since the set has no lower endpoint, we'll use negative infinity in its interval notation on the left-hand side. Then we'll identify what is the upper endpoint. Where does this set stop as we move from left to right? In our example, the highest that our set goes is it gets up to 2. So it stops at 2. So the upper endpoint in our interval notation will be 2. We'll separate these two with a comma. Finally, we need to describe in our interval notation whether or not each of these endpoints is included or excluded. Starting from our endpoint at the right, 2, because we used an open circle in the sketch, because it was a less than or greater than inequality in the beginning, we'll use a round parenthesis to describe the fact that 2 itself is not included in our final answer. Likewise, our lower endpoint, because our lower endpoint is minus infinity, and minus infinity is not itself a number, infinity and minus infinity are always excluded from any interval in which they participate. So likewise, we'll use a round parenthesis to indicate that minus infinity is not included. If we had an endpoint that we wanted to include, instead of using round parentheses, we would have used square brackets. We'll see an example that uses square brackets in the next video. Finally, even though it wasn't necessary in this example, if there is more than one separate piece that you need to include in your final answer, you'll stick those two pieces together using the union symbol, which looks like a U. So to write interval notation for a set, first start by graphing that set on a number line. Then identify your lower and upper endpoints, using negative infinity or positive infinity if one of those endpoints happens to go on forever. Finally, decide whether or not each of those endpoints is included because the inequality is less than or equal to, or greater than or equal to, or your sketch uses a filled-in circle, and use square brackets in that case, or whether each endpoint is not included in the final answer because it's an open circle on the graph, or because the inequality was a strict less than or greater than, and use round parentheses instead.